everyone. This is the second part in a video series where I take a number of different aftermarket and OEM parts and construct a one-wheel type skateboard device. In this particular video, I will essentially be walking through my personal assembly of the front box in this board, and this contains the motor controller, the VESC, and the wiring that creates this back panel to connect it to everything else. If you're either new to the channel or you haven't seen any of the other videos, I will link the playlist in the description below so you can go ahead and catch up. There's a video explaining what VESC is, and VESC is the open source motor controller platform that this particular ESC is based on. There's also a video explaining the parts that I will be using for this build. In addition to that playlist, I'll also have a link to a couple of different things that I've written. On my blog, I will have a detailed article with photos on the assembly of this, explaining some of the ins and outs that I may or may not have mentioned in the videos. And I'm gonna go ahead and mirror that article on a couple of different forums. All those links will of course be available to you in the description and should clarify questions you may or may not have on this particular project. Now, just to clarify something, the original idea for the front box with the motor controller in this build was to use an older version of the ESC and an older printout of the box, and that was a lot harder than I initially thought it would be. And so what ended up happening is I reached out to the folks at Makers PEV, who are the US distributor of this VESC-based motor controller, and they were kind enough to send out an unassembled kit that ends up being this box. Now, this is a kit that they do sell on their website, which I will of course link to in the description below. And I believe you can just buy a fully assembled box. I generally prefer to assemble things myself because I have certain DIY assembly sensibilities that have followed me over from my years of building DIY electric skateboards and working on batteries and having sort of a way I do wiring, and I prefer to build things myself if I can. And so I was very appreciative that they sent out the kit that was totally unassembled, because I did end up redoing some of the wiring myself, which I do explain in the following video clips, and I also will explain in more detail in the article. If you are totally lost about what the hell I'm talking about, this front box contains an electronic speed controller, motor controller, that, assuming you look at a general one-wheel, this is a one-wheel XR, this is the front. This box sits under here, inside here. There is a box containing a motor controller and a whole bunch of circuitry and wiring that controls the motor using power from the battery in the rear. This is something I also explained in that previous video talking about VESC, but if you're totally lost and you haven't yet seen all the other stuff, which you should, that box ostensibly will sit right here and be the brain, as it were, for this board. And so everything else, everything else connects to the back here. This is the power input, this connects to the motor, these are sensors. And so this video specifically is going to be the assembly of this particular box. So let's just jump right into that. Now, we are all set up to bench test, and bench testing is very important. So this is something that I've become very accustomed to before I put something all together, to connect as much of it as I can and bench test it, especially when it involves a new ESC. And I will actually have an example right here in the shop just to illustrate why I do stuff like this. So this is a LaCroix Lone Star, and it's in the shop for some fixins because something happened to the drive system. This is using LaCroix's Falcon gear drives, super expensive, super fancy, and sort of failed. The point is that these motors are new, and one of these motors turned out to be defective out of the box. Had I not tested them, and in a sense bench test them to make sure that they worked, I would not have found out that this motor is defective, and I would have reassembled this entire gear drive to find this be defective and then have to tear this whole entire thing apart. So I did save myself probably an entire day's worth of work just by bench testing. And so that is why I bench test everything I can. Now back to this, I've got most of it hooked up. The motor is hooked up with this adapter. I'm going to change this and make my own adapter for a specific reason, but the rest of it is pretty good to go. The power button's here, and I do have the Hall sensors. Well, this is the sensor plug for the motor, and I have the foot sensor hooked up to the plug adapter for the ADC port, which I will explain in further detail farther on down the line, but everything is hooked up and I just have to plug in the battery. I made an adapter for the battery specifically to avoid the spark that happens when you plug in a battery source to something that has quite a bit of capacitance, which this does. This does have an onboard on and off switch. However, it is wired to be, I believe, a sleep mode to turn it on and off, and not an anti-spark switch, which is what other ESCs sometimes use. And so when you plug this in for the first time to a power source, there is an arc at the plug. And so to alleviate that, what I do is I just use an XT90 plug, which has a resistor on one of the barrels. And so that's the adapter. That way I just plug this into that. And that's the part that I connect last to avoid the spark. Does that matter? Do you have to do that? Probably not. But if you are going to bench test this and you're going to be unplugging this and plugging this in several times, then it's a good idea to have an XT90 interface. All it really is just having a female XT60 go into a male XT90, and that way you can plug in the XT90 last and that resistor will prevent the spark. That's not something you need to do in the box. That is just something I'm doing for the bench test to prevent any unneeded wear on the tips of the pins in the XT60 connector. So when I bench test, I usually unplug and plug in my bench test battery over and over again. And so rather than wear out the pins, that's what I'm gonna do. And as you can see, make sure this is off. The XT90 does not spark, so that's good. Power source connected, turn her on. Fantastic, she turns on. Everything's kind of out of the way. Now, this is something else I'm going to do before I do the rest of the prep, and I am going to update the firmware on the little FOCer. Now, Surf Dado, again, whose information I will link in the description below, is often working on his own version of the firmware, and so it's a bit of a fork, and he's implementing certain features that are useful for this particular kind of build. And so this is very much installing a custom firmware, but the process is the same as updating firmware on any VESC-based ESC. And so we have still our bench test setup. We're going to turn it on. It is connected via USB-C port on the FOCer, and it should be detected. Once you hear that it is detected, you just connect, and that is great. Detects it, connects it, fantastic. Go over to the firmware tab, and I will display this in the configuring part, but installing new firmware, reflashing firmware is something that I personally always do with a wired connection. You can do it over Bluetooth, however, it takes longer, and if your Bluetooth connection is spotty, so if you don't add an external extra Bluetooth, or you're having Bluetooth connection issues, it can really screw up your firmware updates or reflashes, and so I tend to do it the wired way. It's just a bit easier. So on the firmware tab of VESC tool, whoop, boom. And can we zoom in a bit more? Yes, we can. Clear image zoom for the win. So much better than screen recording. So on the firmware tab, we go to custom file. It's already selected it. I'll have a link to Dado's GitHub where he has the files, and so you just go to the file that you've downloaded, and he has a stable release. We're on version 4, and you scroll down to the hardware version that you need. Chances are you're doing this on either a FOCer v3 or in this case a v3.1, and VESC default.bin is the firmware package, and then you would go right there to all, and uploading firmware to the wrong hardware will damage the VESC for sure. Are you sure that you've chosen the correct hardware version? Triple check that you have the correct hardware version, And as long as it is, so this is a FOCer v3.1, this is the firmware for the FOCer v3.1, and so that is correct. And so you upload it, it flashes it, it does its reboot, and then you just start all over again and set everything back up. So that's what I'm doing before any of this stuff goes together, because I prefer to do it with a wired connection. All right, so there's one more small modification I got to do to this. It's nothing catastrophic, but so this box has posts and slight wall here with protrusions that fit into the 6 slots that run through the PCB into these MOSFETs, and so that is what supports this in the box and then gives you compressive force with the heating pad up against the heatsink lid. And so these 3 motor phase wires sit on one side, and then these capacitors sit on the other side, and so the post sits right between them, and so there's not a lot of space there. And then this has to loop around, so this is a very, very tight fit. So the power lead goes there, from what I can gather, and so that sits through. Focus, damn you. So the power lead goes through because the main Molex connector to the battery box is right here. And then the motor connector sits right here on the left. So this is the front of the board, this is the left, and this is the right. L makes a left. And so the power lead in from the Molex goes here, and so this has to sit across like so. And then these loop around here. So these go in, like there's a gap right there, and those go out that way, and then they'll connect to the connector here. And so then you fold, and then you gotta manage this whole thing. And so this line of posts is sitting in between those capacitors and the exit points of the motor phase wires. However, this post nearest the handle cutout is kind of a bit of a toughie there, because there's just not quite enough space, and what you end up with is just a little too much of a gap. So it doesn't sit as flush as one would like. And you can kind of feel right here on this side, it sits perfectly. But one wire, I think, is protruding towards that post a little too much. And I'm not entirely comfortable just forcing that down. So what I'm gonna do is, it's this wire. So I'm just gonna reflow the solder right here and lift this up so it's pointed this way. There's plenty of vertical clearance down to the bottom of the box, and so I'm just gonna lift that up. So this is not something you should do unless you are comfortable reflowing solder joints, especially larger solder joints, on a PCB. I am comfortable enough to do it without destroying it, and so we're gonna use a massive amount of flux, you know, a whole lot of, well, not a whole lot of heat, but a whole lot of an appropriate amount of heat. And we're gonna free flow this wire to point it up a little bit, just kind of an upward angle. All right, so at first I was just going to move the position of one of the motor phase wires, which I did, and it gave me a bit more clearance between the capacitors and the phase wires for that post in this box to sit. And it was fine, but it wasn't a fit that I really liked. And also the solder had wicked up the wire a little bit, and it made about 1/4 inch of it kind of rigid, and I wasn't happy with that. So long story short, I took out all the old phase wires, and these are new ones that I resoldered on. So what I did was I actually wicked away a lot of the original lead-free solder pools on each of the phase wire connections, and then I reflowed it with my leaded solder, the 6337, and flux, and cut new wires, moved the bullet connector barrels over to new wires, and then soldered those on, cleaned up. We're back to bench testing just to make sure that this doesn't blow up, because again, I'd rather it blow up on the bench than in the board. And I didn't really do all that much that's crazy. All I did was that I just spoke about, and most people won't have to do it, pretty sure, but it does serve as a point of, not as a lesson, but just something to really keep in mind. When you're doing DIY stuff, you are indeed doing DIY stuff. So when I embark on a project, I kind of try to keep this mental note that I may actually have to do something myself, whether it's a kit or something. Generally, if you're buying parts and you assume you're putting them together, there is a chance you may have to do a lot of it yourself. Hence, do it yourself. Now, I imagine that if one were to buy the complete front box from Maker's PEV, the folks over there will manage all this for you. And that's great. And so if you're not comfortable reflowing solder pools on a PCB, then don't. It would be great to have those skills, but if you can't do it, don't do it, because you don't want to screw something up so badly that you hurt yourself. And so that's the sort of thing. Do you pay more money or do you do it yourself? And I like to generally kind of do stuff myself. And so that's where I'm at right now. Point is, I ran motor detection again. It did not blow up. And so we are in a decent place, and motor's doing good. Motor's doing good. Woo! Whoa! Oh, easy there, big boy. It's only clamped down on one end, but so that's the duty cycle. So at 12S from the bench test battery, it doesn't actually spin that fast. When it's at 20S, it should spin a little bit faster. But anyway, so this is fine, and this has been well, yeah, I guess fixed. This has been made more to my personal taste. And so now the box can go together. I've already redone one connector for the box, and I'll mention these in the next clip. If you see something that's different from what's being offered by Maker's PEV and you want more details on it, it will also be in the write-up. So before I even post this video, I will have done the write-up both on my blog and on the forums. So, all right, a few days have passed since I last recorded anything on this, and mostly waiting for parts, for something to dry, all that good stuff. And so just to quickly walk you through what I made in terms of changes, this was the stock connector for the motor phase wires. This is one that I just made. This was the stock 16-pin Molex. I took off the XT60 and those wires and this plug for the charge port because they ran together in parallel into the same pair of pins. I replaced that with silicone wire again and my own XT60, a little bit longer, and separated the charge port connector here. So I jumped a pin space and put them there, positive on top, negative on the bottom. 16 gauge silicone wire, XT30, and then next to that is a small 2-pin JST 2mm pitch for the CAN bus connection. And the charge port is the same. I just removed the stock connector and again replaced it with silicone wire and an XT30, and I added a charge port fuse. And so those are the changes I made to the wiring. right, and so this is finally done, and it's all closed up. There was something that I thought I was recording on that I changed right at the end, and so I'll just mention that now. So these front bolts, well, screws and nuts, the front part of them, the ones that are included are M3 by 10 millimeters, I believe, and they were fine. Also, there were some M3 sized nylon washers. I had assumed that they went there, and I remember seeing photos of them not going there, and so I figured that was wrong. So I went and checked and could not find any picture of this box with the nylon washers. There's some mention on the Flow Glider site that those washers are for if you want to install a light PCB, so I don't know where that would go in here, but anyway, so it seems that they're not for this part of the lid. So I took the washers off, the nylon washers, and the 10 millimeter long screws were sitting a little bit too proud. I don't know if they would actually cause any clearance issues. I doubt that. They're probably fine, but they're sticking past these nuts, and so I swapped those to M3 by 8. So these are 8 millimeter long M3 countersunk head screws, and Loctited these nuts, and so that makes them sit just a hair above, like a half a thread, and tighten this down a little bit more, just a half a thread above the surface of the M3 nuts, and that seems fine. Everything looks good. Everything came together nicely. Thermal pad is in place, and you get that nice little clear-ish schmagooch on the bottom. So, front of the board is done. There you go. See, that's some of that's actually the thread locker that gummed up there. This is done. The next step is the battery box in the rear and the harness that connects to here. So this connector is for the motor, and then we're going to do this. So I got to pin up a new harness with that connector and then shrink wrap that down to the back. And so oddly enough, that the time that I'm filming this clip, I'm looking around for them. I have a couple of boxes here. Here's one. And so what we're going to do is we're going to futz around with some boxes. This is the stock Onewheel XR box that was purchased used for an exorbitant amount of money because the used aftermarket be like that. And this is a 3D print of the Fungineers Funwheel box, which also should fit, and that looks really nice. And also, what came in the mail today, bear with me, is a new box that's quite pretty. The Torque box. I'm dropping everything. Here's the lid. Very nice, but this is a polycarbonate box that won't fit a stock bumper, but it will fit a larger battery, and this thing is super, super pretty. I was popping some cells in this to see what I could do, and this is some spacing fish paper dots for reference, but this thing is pretty. So BMSs are on their way. I got another couple of BMSs here, so we're gonna figure out the whole battery sitch before too long. So as always, thank you for watching. If you stuck around this entire time, bless your heart, and I'll see you in the next video. Take care of yourselves.